Welcome to a lesson with Dr. Powell. Let's take a look at the idea of arc length or length along a curve. Now, if we want to compute the change of the length along a curve as we go from one position to another position, we can use a definite integral. All we need is the derivative of the arc length. Now let's think about arc length. Now, if a function is differentiable, meaning it has a derivative, then up close, the function will look like a straight line. So this function isn't up close enough because really these two guys get to be just about the same here. And so kind of thinking close enough, we're going to get this being approximately this guy right here. So the change of the arc length we're going to picture as being this hypotenuse right here, at least differentially, and it's going to approximate the actual change of the arc length. Now, let's look at this triangle for a minute and think of a triangle that's similar to it. If we divided all the sides by dx, we'd have dy over dx and 1. And to get what the hypotenuse is, just remember this is a right triangle, so we can use the Pythagorean Theorem. So that means that the ratio of ds to dx, this ratio right here, is the same in this triangle, is the same as the ratio in this triangle for corresponding sides. So we get that the derivative itself, by similarity of triangles and ratios, we get will be this. This will be the derivative. Now, using this derivative, let's go ahead and look at a specific example. We have y is equal to x to the 3/2 power. And let's find out what the arc length derivative is in this case. We just kind of put this in where dy dx is. We take a derivative of this to get 3/2 x to the 1/2, square it, and we end up getting 1 plus 9/4 times x. With a little u substitution, u is equal to 1 plus 9 over 4x. This will look like square root of u. Of course, we have to replace dx with du over the derivative of u, which is just 9/4. Okay, and then upon taking the antiderivative of this particular, this is really 4/9 times square root of u. You get u to the 3/2 power, but then multiplied by 2/3 times that 4/9, which ends up being 8 over 27. So we get this as the antiderivative, then we plug in 13 over 4 to 1. Notice how the bounds change for u. Why is this a 1 here? That's because these are x values, x equals 0, x equals 1. So when x is 0, what is u? So plug in x is 0, you get u is 1. When x is 1, let's see what u is. When x is 1, it's 1 plus 9/4, which is 13/4. So then we plug this value in and that value in and subtract, and we end up, after some simplification and factoring out 1 over 27, we end up with this right here as the arc length. Thanks for watching.